This question is from the GATE Physics paper 2021. This is a MSQ having 1 mark and the topic of the question is electromagnetic theory. The question is, as shown in the figure, an electromagnetic wave with intensity I with subscript I is incident at the interface of two media having refractive indices N1 equals to 1 and N2 equals to √3. The wave is reflected with intensity I with subscript R and transmitted with intensity I with subscript capital T. Permeability of each medium is the same. The reflection coefficient is defined as capital R equals to I with subscript R divided by I with subscript I, and the transmission coefficient capital T is defined as I with subscript T divided by I with subscript I. So we have to choose the correct statement. Option A is R equals to 0 if theta I equals to 0 degree and polarization of incident light is parallel to the plane of the incidence. Option B, T equals to 1 if theta I equals to 60 degree and polarization of the incident light is parallel to the plane of incidence. Option C, R equals to 0 if theta I equals to 60 degree and polarization of the incident light is perpendicular to the plane of incidence. And option D, T equals to 1 if theta I equals to 60 degree and polarization of the incident light is perpendicular to the plane of incidence. So as this is a MSQ, so it is possible to have multiple options correct for this question. Let us see the solution part now. According to our question, we have an interface separating two media having refractive indices N1 equals to 1 and N2 equals to √3. Now, one unpolarized light is incident on the interface with angle of incidence theta I and the angle of reflection is theta R and the angle of transmittance is theta T. Now, the reflection coefficient R is defined as IR by II and the transmission coefficient is defined as T equals to IT by II. Where IR is the intensity of the reflected light and II is the intensity of the incident light and IT is the intensity of the transmitted light. Now we will first calculate the Brewster angle theta B at the interface. First let us discuss what is the Brewster angle theta B. So Brewster angle theta B is basically the angle of incidence of an unpolarized light on an interface such that the reflected light will have only the component of S polarized light. That is, the reflected light will have electric field only the perpendicular direction of the plane of incidence. There will be no component with the electric field in the parallel to the plane of the incidence. That is, p polarized light will not be there. So according to the Fresnel's equation, the reflection coefficient for the p polarized, that is the parallel component, is tan of theta I minus theta t divided by tan of theta I plus theta t, and the reflection coefficient for the S polarized light, that is the perpendicular electric field to the plane of incidence, is minus sine theta I minus theta t divided by sine of theta I plus theta t. Now if we look into these relations carefully, we can see for the first relation, if the theta I plus theta t is 90 degree, then this tan of theta I plus theta t is infinity. So effectively we will get this R parallel is 0. But for this condition theta I plus theta t equals to 90 degree, this R perpendicular is not equal to 0. So from this condition we can get the estimation of Brewster angle. So under the condition of theta I plus theta t equals to 90 degree, only the S polarized light, that is the light with electric field in the perpendicular direction of the plane of incidence, will get reflected and theta I will be known as Brewster angle. Now we will use the Snell's law to estimate the Brewster angle. Now under this condition, the angle of incidence theta is basically our Brewster angle, that is theta b. So by applying this Snell's law, we will get sine theta b by sine theta t equals to n2 by n1. Now our theta t is basically 90 degree minus theta b according to our condition for Brewster angle. So effectively we will get sine theta b by cos theta b. So our n2 by n1 basically sine theta by cos theta b, that is tan theta b equals to n2 by n1. Now according to our question, n2 value is root 3 and n1 equals to 1. So in our case the Brewster angle is tan inverse n2 by n1, that is tan inverse root 3 by 1. So theta b equals to 60 degree. Now we'll consider 2 points. First point is, if the polarization of the light, that is E vector, is in the plane of incidence, that is P polarized light, then at the angle of incidence theta equals to theta b, we have the reflection coefficient equals to 0 and the transmission coefficient t equals to 1. So this is the case of total transmission of P polarized light at incidence angle theta b. And the second point is, if the polarization of light, that is E vector, is in perpendicular to the plane of incidence, so this is S polarized light, then at the angle of incidence theta equals to theta b, we have the reflection coefficient not equal to 0 as well as the transmission coefficient not equals to 1. So this is the case of partially reflected and transmitted light for the S polarization case. Also, for the angle of incidence theta equals to 0, that is normal incidence, the reflection coefficient not equal to 0. So if we consider all the points, then we can conclude only our option B is correct for this question. According to our solution, the correct option for this MSQ is only option B, that is T equals to 1, that is transmission coefficient equals to 1 if angle of incidence theta I equals to 60 degree and polarization of the incident light is parallel to the plane of incidence.